Howdy, AP PreCal. It's Miss Kosh. A little more notes on polar. So I taught it slightly differently, perhaps, but I found these notes from Miss Vicki Carter, and thank you very much. And so I wanted to teach through it just to give you another way to see the same sort of stuff. Okay, so basically, a polar grid allows us to take the unit circle and change the radius, basically. So here was the radius of 1, 2, 3, 4, 5, and so forth. It looks like on this one that we've divided it into the pi over 6 and pi over 3 family, sort of. Also, like we're adding pi over 6, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4, 5, 6. Okay. So when we write a coordinate, it's always written as r theta. But what makes more sense to me, to be honest with you, is to think of the theta first and then find the r. So this very first one, we'll call this point A, is going to be pi over 6, which is here, and then it has a radius of 3, which is this. And so here is point A. The next one, 2 pi over 3, well, 2 pi over 3 is this ray right here, and it's got a radius of 5. So the radius of 5, so we're coming out 1, 2, 3, 4, 5, and this, I will call this point B, and here it is B. Okay, the next one, pi over 4, oh, that's going to be here between these two, because this is pi over 6 and this is pi over 3. Often I see these with twice as many lines, or, well, each of these sections has a line through the middle of it, maybe I'll say that, where they give us pi over 12, pi over 6, pi over 4, pi over 3, 5 pi over 12, pi over 2. Go check out my other video that I just posted if that didn't make any sense to you. Okay, so pi over 4, but instead of moving in the positive direction on pi over 4, we have to turn around and go in the negative direction. So here's negative 1, 2, 3. So this is going to be negative 4, and we're somewhere down here. Let's call this point C because we're oh so creative, and there you go. Okay, the next one is saying now go negative 3 pi over 4, which means we start here and we go in the negative direction and then have a radius of 4. And actually, this is also the point C. Those two landed in the exact same spot. Okay? So now convert from polar coordinates to rectangular coordinates. Well, so if we want an x coordinate, we notice that she has in the notes here that this x is equal to r cosine theta. If you think about it, any random angle, here's our theta value, here's our r, here's our x, here's our y. We know that cosine of theta is equal to x over r, which means that x is equal to r times cosine theta. Likewise, sine of theta is equal to y over r. Therefore, y is equal to r sine theta. The good news is this doesn't go away. This will be relevant in polar, in vectors, in parametric. It just is in complex numbers. We'll see this a lot. Okay. So we can either think of, well, here we go. We'll say that the x value is equal to r cosine theta, which is cosine of pi over 6. We went up a little, is 1/2. 3 times 1/2 is 3/2. I'll write that down in a second. Y is equal to r sine theta. This is 3 times root 3 over 2. And so the new coordinate, the x value is 3/2. The y value is 3 root 3 over 2. Then we likewise with this one, actually I'm lazy, I mean efficient. 3 pi over 2 is down here. We have a radius of 4, which just means that this is the point 0, negative 4. Now you can do the trig, but I didn't feel like it. Okay, hopefully that was helpful. Let's see. Okay, now converting rectangular coordinates to polar coordinates. So she tells us that r is equal to x, the square root of x squared plus y squared. Think about this. We have the Pythagorean theorem. R squared would equal x squared plus y squared. Therefore, r is going to be the square root of that. And likewise, hang on, come back. Likewise, this theta is going to be found using tangent. So tangent of theta is y over x. So theta will be arctan of y over x. And notice how she writes this. It's y over x when x is greater than 0, which means that when x is greater than 0, we are living in quadrant 1 or quadrant 4. That's where x is positive. And then we would have to add pi when x is less than 0. That puts us in quadrant 2 or quadrant 3. Okay? I don't always think of it in terms of comparing it to what happens with my x value, but I do think, what quadrant do I want to be in? Do I need to add pi or do I not? Okay? So this is 3, negative 3. So here is 3, here is negative 3. I see that this is a 45, 45, 90 triangle. I can use these equations, but I just know it's a 45, 45, 90 triangle. And so the hypotenuse is 3 root 2. This angle is a 45-degree angle. So convert to polar. One of the ways that we can do this is say that that is 7 pi over 4. There are other options. If you go check out my notes, you'll see how I make everybody give me 4 ways of describing this point. I'll do positive, negative, positive, 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 negative, negative, positive, negative, negative. Oh my goodness, okay. Anyway, let's look at this one. Oh, I think, I'm sorry, I'm moving my paper. I think this is similar to an example on my notes. Negative 3, positive 4 puts us here, which, that was a little excessive with my coloring. Negative 3, positive 4, this is a 3, 4, 5 triangle. Okay, so its radius is 5. Its angle would be arc tan of y over x, so 4 over negative 3. I don't usually like to put the negative there, but if you follow her directions, our x is less than 0. So from this one, we need to say plus pi. And there we go. Oh, using technology. Ooh la la. I'll keep going. I'll finish this, and then we'll come back for another video for her complex number part. So convert the polar coordinates to rectangular. So we need to be in radians. Let's see. I am in radians. I can see it right here. Here was what I was just doing in a previous video, but I'll get rid of it. Okay, so we need, the x value is going to be 2 cosine pi over 5. There you go. AP wants the third decimal place nice, but if it's not a bad idea to give me the fourths in case you mess up. And then we also need 2 sine. It would have been easier, pi over 5. Oh, nope, hang on, pi over 5. 1.1756. That would be great. There you go. Did that make sense? I don't know that I will write any questions like that because I think it's too easy. Okay, convert the rectangular coordinates to polar coordinates. This is going to be a negative, negative. So we're looking at something like this, negative 5, negative 12. This is a 5, 12, 13. And then we need to find this angle. So we'll say theta is going to be arctan of negative over negative is a positive, but because this is in quadrant 3, we have to add pi. Okie dokie. So inverse tangent of, what was it? What did I just say? 12 over 5? Notice this is in quadrant 1, which is not what I want, so I have to say plus pi. I did that on purpose to show you. So I would imagine we would say something like, let's see if you can see both my, we would say this is the coordinate, in polar coordinates, r is 13, theta is 4.3176. And that's the approximate value. I prefer the exact, to be honest with you, but anyway, that's fun. All right, subscribe to the channel. Come back and see me.